All right, welcome back to this dynamic analysis or dynamic modeling part 2, where I'm going to discuss with you. I'm going to show you on the EViews estimation on the forecast error variant decomposition and the impulse response function, or in short, it's called variant decomposition and impulse response function. So we go to the notes, right? This is what we discussed in part 1 actually, right? Especially when we discuss on this part in part 1, where we talk about the dynamic analysis, where we mentioning that what is going on in the dynamic analysis. These two parts which is important. One is this, the other one is this. So we're going to discuss these two. What again, I recap back. What actually these two are doing is actually to see whether how this estimation beyond the sample. We want to see whether the impact going to die off, or what's the impact of certain variable towards certain variable, or certain policies toward the other policies, and so on and so on. And it's going to partition, especially in variant decomposition, partition the variance for certain variable proportion attributed to innovation or shock of each variable, including its own in the system. Why we need to do this? Because we know it acknowledge that in economic shock, for example, of what's happening now for the past nearly 1 year now. Now is December, officially it happens in December 2019, and we want to know such an event, how it's going to impact and what's going to happen outside the sample, beyond the sample, and so on. So it's like a forecasting ability. Doing forecasting, this is the formula. And then we similarly for variant decomposition, similarly to of variant decomposition to impulse response function, this one is like a mapping or visualization of the map within the system. And this generalized variant decomposition is a better option, and generalized impulse response function also a better option. Normally, generalized impulse response function are represented by graphical illustration, and the variance decomposition normally represented by the percentage. So we go back to this one. All right, let me escape this thing first. We go back to EViews, right? This is the EViews that we are estimating. Go back to the result of co-integration. At least we open as a group. We do the co-integration of Johansson-Jussieu system co-integration. We use LAC2 in this example, right? But again, to choose the optimal lag, you always have some other selection criteria. But for the purpose for this class, we just use the one that automatically selected by EViews system. That will solve a lot of issue, especially on your side. All right, so we get this result. You still remember that this, and then we go back to the VECM, go to proc, go to vector, map vector error correction. We go here with lag 2, same lag as the Johansson-Jussieu test. You got this result. All right, this is a similar result as what we get from these slides, and then this result of the variance, of the VECM, right, and which I put up in the last chapter, and also I show to you all in the class on chapter number 7. All right, so what we need to do next, to go to VDC, click view, click variance decomposition, go view. You have variance decomposition here, the impulse response here. You have to know that we are doing VAR here. We're doing VAR, but in this case it's VECM, because it's a special case of VECM is a special case of VAR. So variance decomposition here. So you have multiple choice here, right? Here, less option in these slides. You have table, multiple graph, combined graph. Here, the latest EView have more option here. So we're going to do table. The VAR, the variance decomposition, going to be in table, and the period you can extend up to 50 maximum. I'm going to use Chokesky decomposition in this sense, although this have some limitation. The idea is that EViews do not have generalized variance decomposition option to go ahead with. So we present that into table, not a combined table, a table itself, and you click OK in this sense. So we have three variables. So basically, it will come out something like this, some result like this. This is the result, variance decomposition for LGDP, variance decomposition for EXPN, and revenue, right? Expenditure and revenue for 50 period. 50 period means 50 years beyond the sample. So let's say I choose this one, 50, and click OK. Change the period to 50, right? And then you can present that the table that I already give you in the table that I given to you. You can fill up this table with the figure that's available here. All right, there's a figure that's available here from EViews. Right, you can copy paste this thing easily. Normally, this is what I do. Normally, this is how I do it. Right, let me show you, just show you what I'm doing normally. Right, normally this is what I do. I put it into Excel. Where's my Microsoft Excel? Normally I put in Excel, and then I will put it nicely in tabular format in Microsoft Word. So it's like this, right, in Excel nicely, and then you could delete off whichever is not relevant for you. So in presenting the result, normally we do not present 1 to 50 for each. We maybe present like this. For example, 1, 4, 8, 12. For example, it's up to you how you're going to present it, but you don't have to present it all. Why? The reason being is simple, is that what's the meaning of this? This means that we shock LGDP. So I mean, something happens to we electrocuted LGDP, and then we see the impact towards itself and the other variable. So if you see that towards itself, this portion here, this first column here is not important. This SE is standard error. The only important is this 3 column. All right. So in period number 1 means that year 1 is 100%. Then it reduce. You see the impact reduce. The impact reduced in the 50 years down the road is 73%, but the impact of revenue increases. Right? If you can plot this graph, it shows that increase, and the impact of expenditure actually quite consistent. So this is the meaning here, and we partition this. We add up this thing. If you add up this thing, it's surely 100. That's why I have an extra column here, which is called CU. CU is cumulative. So we add up is 100. Add up everything is 100. So cumulative, you can see that the impact of cumulative, for example, here LGDP, we can see that the impact of these two, right? This one, the revenue plus the expenditure. Other than the GDP itself, right? So you can see that this is the interesting part about the cumulative, so that you can see the aggregate of the total within that particular the other variable towards the variable of interest here. Right, here is when you shock the GDP. Right, so interesting. This is what happened when we do this kind of estimation. All right, so let us move on. So this is variance decomposition. Right, this is variance decomposition. I show you how we do it. So now let's move forward. Now we go to impulse response function. Right, impulse response function. Here again, you go back to view. You go back to impulse response here. Right, go to impulse response. So you have what we're going to do here again is 50 period. We have multiple graph. We go in the impulse definition. We go generalized impulse, because here EViews they have generalized impulse response function, or GIRF, but they do not have generalized variance decomposition. So we use the Chap8. It's okay, no problem. So you click OK, just change this thing and you click OK. Then you can come up with multiple graph here. So in this sense, you have here you have 9 graph, not 12, sorry, because only 3 variable. This is, you see, GDP towards this self, expenditure towards this self, and revenue towards themselves. All right, and the rest of it is as mentioned there. Response of GDP to GDP, response of GDP to expenditure, response of GDP to revenue. Means that one period shock or the standard deviation innovation shock. And then what we are trying to see here, let me copy down this thing. This thing all can be copied. All right, let me try to copy this thing and put up in maybe in Word. Right, put up in Microsoft Word, and you'll see what happened. Okay, you see here. So the interest here, is that you want to see whether, for example, this variable or this variable, or GDP to GDP might not be important in that sense. So response of GDP to the shock in expenditure, response of GDP to the shock in revenue. So you want to see, let's say, expenditure shock, what will happen to GDP, and you see the GDP fluctuate around until about 15 years down the road, and after that it's quite stable, and the impact is positive. Here the impact is negative. So interestingly, you can say that the impact of expenditure towards GDP is positive, which is true in the sense of Keynesian. Revenue here, interestingly, shows that this negative impact is positive at first, and it goes to negative and fluctuate, not so volatile, and then after that, straight to towards the negative side, and then towards the stability after maybe 25 years down the road. So this is, and then you can see all these things. So you would be able to see that some of the variable do not pass by the zero line. Like for example, this is positive, this is positive, this is positive, positive. Most of it is positive, except for this is negative. Right, so response of expenditure towards GDP. GDP, what happened? Something happened to GDP. GDP, what will happen to the expenditure? So this is how you could interpret this thing easily in that sense, right? So you can see the results here, right? Click generalized impulse response, you can see the result like this. How we're going to interpret is a matter of interpretation. How we interpret normally for this part, for generalized variant decomposition, for the variant decomposition normally, right? Generalized impulse response function, we interpret the we're going to interpret the positive and negative impact, and then we also interested how long does the impact die off. It's off, right? How many years, quarters, or month, right? Depending on your data. This is from generalized impulse response. Let me go and find back some of the article which is related to you in that sense. So here, like I mentioned to you, this article by Prof. Ahmad Zubaidi. This article shows the understanding or the interesting part about. Let me make this thing bigger. Make this thing bigger. Okay, full screen, no? Normally have option. Yes, that's the option. So this is the impulse response function, generalized impulse response function. You can see that the idea here is that we shock the exchange rate, and then we want to see the impact towards trade balance. As I told you in the part one, these are very much related to J curve. Means that devaluation will impact the trade balance at first in negative, and supposedly will impact it in the longer terms of being positive. That's what the theory says, and it proved in that way that this might be right. And here it's not really a J curve. This one is not really a J curve, right? But the means that the impact do not die off. The impact also do not die off, but at least it goes back to from negative to positive. Means that there is a chance that after devaluation, with this Thailand US exchange rate, the trade balance will go back to positive. So this is how you might be able to explain in that sense for this application. If not, we just moving ahead to explain what is happens. Let me go some article which is related to us. Right, for this particular, I don't think this one I have impulse response, but anyhow, we will settle with that few article on talking about impulse response. You can always refer to numbers of article which be example. I will show to you surely in the class of how this impulse response function being used in that sense. Right? How this impulse response. This is the notes for impulse response function. how is this is from the theoretical point of view, but from application point of view, as I told you just now, we are interested to see whether the impact is negative to positive or positive to negative or negative all the way. And then the other part that the interest is whether the impact die off or whether it's going to be it's just a temporary shock or it's just permanent shocks, right? And for the variance decomposition, decomposition, the interest is on the percentage, percentage of how big towards when I mean from one time to one period of time. Let's say from year 1 up to year 50, how's going to be the impact? As I told you just now, as I showed to you just now, as based on this slide just now, right? For example, like this. You can see that the impact of GDP towards themselves is actually die off, and this one revenue actually increases, right? So in terms of percentage, that's what you can explain in terms of percentage. And the other interpretation of this variant decomposition is that from here you can identify whether the variable is actually exogenous or endogenous, right? Exo or endo. You can see here from this bold one is actually refers to the variable itself. So here you can see that this variable is actually very comparatively, this is exogenous. Comparatively, this is the most endogenous, and this one is at the middle. So you can rank them from exogenous to endogenous. What does exogenous mean? Exogenous means that whatever shocks happen to this particular variable, it still have some impact towards themselves even after certain years. And here the other way around means that other variable actually impact them strongly. Here in this case, this variable revenue affect expenditure very strongly, which is true in terms of theory. And here, in terms of revenue, GDP impact revenue very strongly, about 40% up to 50 years down the road. So this is long-term planning of what here from the data that we have. All right, so basically this is what you can present. You can always present that in nicely in this nice table. You can have a look of this. Where is my table? Yeah, this is the table that I give to you, right? From the previous chapter. Right? Presented this, you can always explain that, and this part also explain. This one we didn't do it. This one is in another program called Microfit. I will not show it to you. I'll not show it to you. Not here. All right. So, but you want to learn more about Microfit. Why not? I can always show to you. Additionally to any group of people that are interested. So anyhow, I think we will just stop here, and thank you very much for listening to my video, and we're going forward towards the last part of the class, which is actually on panel analysis. More videos were up for the panel analysis. Thank you very much, and adios.